أحبنا الحضور يكون أكثر، يهمنا الحقيقة. ها؟ تعرف أنت لازم يكون تقديرا. لا والله ما أنا تعب، نتمنى بس إن شاء الله نطلع شيء. سوى شوي هزة لأنهم بدأوا الآن يفكرون يعني ليش ما نحاول نفتح بس إنهم يسهرون يعني المشكلة تصدق على ولا Good morning, everyone. Today we're going to continue our workshop with now we're going to start for trade American circuit break authority technology. Represented expert Johnson and Brandley and Cleven. And is there anyone who gets going to be start? Cleven or? Yeah? All right. Okay. Thank you.
Good morning. Okay, sure. So Gene is just asking me to explain the purpose of the presentations today. Yesterday was a bit about the history of UL and some comparisons to the IEC standards. Today's focus is for the different presentations to help the group here understand some of the newer technologies that we are employing in the NEMA markets. And so we have actually 4 presentation areas and 4 presenters who will be sharing information today. The subject matter is around ground fault circuit interrupters, arc fault circuit interrupters, arc flash protection, as well as communication within electrical systems. And so I'll be starting with information on ground fault circuit interrupters, and I'll go through that and then turn it over to the other presenters. And at the end of those, as the schedule indicates, we'll get together, the 4 of us will join for a question and answer session. To ground or to earth. Couple of things that cause problems with respect to faulty insulation. There could be wiring faults, and there can be current going to the earth even if there's no fault. When you look at the types of devices that are on the market today and globally, there's voltage-dependent devices, and these really are devices that tend to be electronic in nature, basically the NEMA style devices used typically in North America. They'll use current transformers to identify faults, and they will have the use of some kind of an electromagnetic trip function in order to interrupt the current. There's also voltage independent devices, typically called residual current devices, and these are electromechanical devices, and they do not necessarily require the use of a separate trip circuit to trip them. So with respect to some of the specifics on the voltage-dependent devices, they, relative to the voltage-independent devices, will have a trip threshold that's a maximum of 6 milliamps. And I have a chart to help you understand what that means later in the presentation. But that's what we typically call a let-go current. So the human body, when it's faced with 6 milliamps of current flowing through it, a person, if they're holding on to the wire, for example, can still let go of the wire when 20 milliamps is actually, or sorry, 6 milliamps is flowing through you. The voltage-independent devices will tend to have a 20 milliamp threshold, and this is a threshold that will cause the body more physical pain and tends to be close to a limit where ventricle fibrillation will happen. And so it's much closer to causing the body much more harm than the 6 milliamp level. A couple of the other things that are going on with voltage-dependent devices, the NEMA style, is that we've recently made some changes to the UL standards that help the device sense for itself when it's reached its end of life. We were seeing some issues a while ago where voltage surges were causing some lack of reliability in the products, and those issues really have been addressed through significantly better robustness to voltage surges based on the UL standards changes that are really defining higher thresholds for these devices. And in addition, they're also identifying and self-testing, and they give the user an indication and will actually take themselves out of service if they're not functioning correctly. So they really tend to be very safe devices and will take themselves out of service if they're not functioning correctly. And I was mentioning just a little bit ago about a chart which really helps us understand the different thresholds for when a body is subject to an electrical shock and the different levels. And so you can see on the chart where the UL definition of the trip point at 6 milliamps on a voltage-dependent device will really identify that you've got below the 6 milliamps, it's a very slight shock, maybe like a static shock, but it's not something that's really going to harm a typical human. And as we start to get higher in the chart, you start to have more dramatic effects on the human body. And the 6 milliamp threshold is where those effects just start to become really perceptible, and the human can still release themselves from an electric shock. If you look at the 20 milliamp level, you start to get into a zone of extreme pain, possible respiratory arrest. And so that level is relatively high. It won't necessarily cause death. It may or may not, depending on perhaps some other conditions of the human body. But it's a zone where, at least the UL perspective has been that we really prefer to keep the trip threshold much below the 20 milliamps, and it seems that the 6 milliamp has been a well-tested and tried and true method to limit the shock values. Just and this may be a little bit technical, but just really talking about how the ground fault circuit interrupters work. They basically look for current flow in a circuit, and they actually measure the amount of current that goes out to a load and check that the amount of current coming back through the neutral wires is exactly the same level. And they're very sensitive, using a differential current transformer, a sensor, to understand that there may or may not be any loss of current in some place in the system. These also are used on multi-pole devices, so 240 volt loads, line 1 and line 2 going out to the load, and again measuring that the same amount of current comes back. And in a line 1 and line 2 with a neutral, in a similar manner, they'll measure that the same amount of current is coming back on all 3 conductors. So there's different applications. In addition, there's also equipment protection ground fault devices that are sold through the NEMA devices, and these will actually sense in multi-phase applications as well, 3-phase. So when a ground fault circuit interrupter is going to sense a problem with a circuit, what will happen is that the current that's flowing to a load, some of it will be redirected to ground or to earth. And so the load coming back through the return will not equal. So in this example, we've got 6 amps flowing out to a load and 5.9 amps flowing back, losing 0.1 amps or 100 milliamps in this example. And so the current transformer, or the differential current transformer, will actually sense an imbalance, and it'll send a signal electronically to the trip mechanism of the device and actually cause it to trip. There are also very specific guidelines for the timing of the trip that's required as well. So now just talking about areas, I mentioned as I was talking about deaths from electrocution in one of the early slides that over time the areas that ground fault circuit interrupters are required have been expanded according to the U.S. National Electric Code. And so this is kind of a laundry list of areas that we see them, but the general areas are in wet locations. So clearly in kitchens and bathrooms, and then it's really expanded to areas where you may have a sink that's in an area that's not called a kitchen, and so the code has been updated to require that. Laundry rooms, and in addition, if you have an outlet that's close to a shower stall, for example, and other kind of maybe less common areas like boathouses, these are also required for automatic dishwashers and areas like that. And so at this point in time, the code is very comprehensive, really with this mindset of identifying any place that a human can come into contact with a wet location. And probably some other areas not mentioned here, any receptacles feeding outdoor areas where you might have random contact with wet areas, those are also important as well. So probably in this environment, mostly around indoor locations except for last night, but so it's mostly dry outside, but clearly inside it's important to have these devices required. And I think that was my last slide, and I'm going to turn it over to Brad for arc fault at this point. Yeah, sure.
I saw that the harmful current, you said around 6 milliampere. From where did you get a reference from that? Is there a reference you have?
And the answer, the question, just to make sure that the question was about is the harmful current, is there a reference for that? And I had in the fine print, I think, and where I got that chart from. Yeah. And what I can do is I can look this up and get that for you. And
From where is that? Is there any reference for this data?
yeah, so I'm just trying to make this bigger so you can see the fine print. So I have workers' deaths by electrocution and electric hazards and accidents. This is the reference that I have for this information. I don't know if you can see that there. So we can make that available, and you guys have these presentations here.
We have 50 milliampere. This is as international, which is the harmless current.
Yeah.
30.
And I think what we're talking about here is that at 20... Right, and if we look at 20 milliamps, I think we're not necessarily saying that 20 milliamps will harm will cause death to a typical person. We're not saying, you want to jump in, Kevin?
If I may, 6 milliamps, and this work was done by Professor Dalziel, I think, back in the early 70s at Berkeley. He did a bunch of their published works out there you can reference. But the 6 milliamps is when, above 6 milliamps, your hand is paralyzed. It paralyzes the muscle, so you can't let go of the circuit. The 20 milliamps the Europeans have says my heart stops at, above 20. So that the Europeans say, let's not stop the heart. The American one was, let's make it so you can let go.
It depends upon time also.
Yes, absolutely, absolutely.
So,
And there's a curve.
This is the work done of the breaks of itself. The time, how long it will work.
It's
That's
both.
right.
It's absolutely, it's both. And there's a chart that shows it, and it's in, I think the table was in the 943 standard that shows it. There's many publications, but it's a different in methodology, whether the Americans say, make it so you can't, you can let go at that level and detect it, and the European says, just don't shock them, just don't kill the heart. And the European one will hurt very badly. It won't stop your heart, but it will hurt very bad.
I would like to add actually, sorry, Mr. Singh, for the European standard, 30 milliamp is considered as the threshold for the safety. Right, and it's widely practiced. And I believe under IC installation, the use of residual current breaker is much higher than the one, than a North American standard, because it's much more used. And I'm pretty sure that it's working actually.
Oh,
That's why they didn't revise this.
it prevents heart stopping, yes.
Yeah.
Electrocution, it prevents electrocution. The American one goes at a much lower level to prevent shock, even harmful. So if you hold on to, we had a tester in our office one time that you would crank up. You can't hold on, you can't want to hold on much past 6 milliamps. You get big guys that are very strong come in and say, I'm going to hold on. It's very painful even below 20 milliamps, but it's not stopping your heart. It's the heart stoppage one, and that's what the RCD, it will prevent your heart stoppage. Yes, absolutely.
Why is not the freezing? Simple.
Yeah, that's Kevin's perspective of let go current. It freezes your muscles in the contracted position.
In IPCs, there are two different standards for residual current safety. One of them is for covering the electric shock protection, and the other for electric shock as well as overcurrent protection. My question is, are there any UL standard included overcurrent protection?
Yeah, so let me just speak to that.
Well, Jonathan's looking for that. I brought some samples.
So the question was, is there a UL standard that includes both the circuit breaker protection as well as the shock protection, ground fault protection? And there's two ways to protect people from shock in the NEMA applications. One way is to combine the shock protection along with the circuit breaker. Brad, can you please hand him that two-pole device? So the two-pole device with the red trip button is a two-pole circuit breaker that has integral shock protection built in. So it's a ground fault breaker as well as a overcurrent protection together. That breaker complies with UL 489 from a circuit breaker perspective, and in addition, it complies with UL 943 for shock protection. So all of the requirements of UL 943 with respect to ground fault pickup levels, maximum of 6 milliamps, timing of ground fault interruption, as well as all of the requirements for UL 489, that breaker complies with those requirements. There's an alternative methodology we have, which is to feed a circuit with a standard circuit breaker and have a ground fault outlet attached to the end of the line. So a normal circuit breaker would provide protection to the wire. and the ground fault circuit receptacle would provide protection to the connected loads. So there's two ways to go about it. But UL 943 defines the ground fault circuit protection, and UL 489 defines the circuit breaker protection.
Do you have background why IEC the residual current 30 ampere, 6 milliampere?
I don't have that background. I haven't been around, and I think Kevin may have some more information. The question was, do I have the background about why IEC set the level?
Yeah, because this is now it's international. It's becoming international.
Yeah.
And I don't want to say the RCD is bad. The RCD for those circuits prevents your heart from paralyzing.
You saw it?
Your heart from killing you. That is good for that. The American one chose for the 120 volt, 120/240 volt system to say don't get shocked at all. You'll hardly feel 5 milliamps. You will feel 20, 30 milliamps. You will feel it, but your heart won't stop. They went to the heart stoppage. That was the point of the IPC, heart stop. Don't.
They are looking for the safety. 30 milliampere is safety. But if I put a 6 milliampere, maybe anything, small thing will break or open and close. So maybe several times a day.
But you could, anything above, I think it's above 30, you will likely have heart stoppage. That's the thing. So that's why RCDs are good to prevent heart stoppage. No doubt about it. Yes. So that was why that level was chosen. It was for heart stoppage.
No, I am afraid that if I put a 6 milliampere, it means that the circuit breaker for any small current trip.
Okay, so
that's why I have to increase it at least to make safety for me and also safety for the system.
that's a great question. This is about really nuisance tripping on ground fault circuits. And one thing I can tell you, I'm engineering manager responsible for arc fault circuit interrupters, and this is leading into Brad's discussion, as well as ground fault circuit interrupters as their end-use implementations. And I can tell you that we see minimal to zero nuisance trip situations with ground fault circuit interrupters. We've been using this technology since the 1970s. We've refined the technology over a significantly long period of time, clearly from that perspective, 40 years plus. And we see minimal to zero situations with nuisance tripping. So when we see a situation with a ground fault circuit interrupter that was made correctly, and once in a while they're not, of course, when we see a correctly manufactured ground fault circuit interrupter that's tripping in an application, pretty much always there's a problem with the system, or it's sensing a true fault that should be addressed. We really don't see nuisance tripping problems with these devices. We really don't.
Can we say that it is associated with the installation standard, actually, wiring standard you are using for your installation for your site? Because I can tell you here, most of the buildings actually you will see natural leakage of more than 6 milliamps. So your GFCI will be always tripped. While probably that's why the threshold of 30 milliamps works much better in the installations here. I can understand when you are saying in the NEMA standard, when you are using the NEC codes for the installation and the wiring, probably this 6 milliamps is not causing any nuisance tripping. But probably in the installations where we are not following the same wiring standards, 6 milliamps could be a nuisance.
I suppose it could be. I don't know, Kevin, if you have any other information on the wiring standards and what things might be going forward.
I can't speak specifically to the wiring practices here, but I do know that there's an expression about ground faults, and people say, what is the #1 reason for GFCIs to trip? Because of ground faults. So ground faults are not good. Now, if you have them, that system, there is something that is not correct in allowing that current to flow. Now,
products over the years, many years ago, products were allowed to be built with insulations that weren't very strong, that had leakages. Those product standards have all been changed 20 years ago. So there were stories years ago where don't put your refrigeration on a ground fault because it will trip. Those appliance standards have all been upgraded because we know that leakage current is not good at all. So we should work to eliminate leakage currents altogether, but I cannot speak specific to the practice. Less leakage is better, yes.
Just please, I would like to thank all of you to asking, but this is not the time for asking. Please let them continue. After that, you can ask. There is a time for asking, which is 20 minutes, or we can take more than that. Please. Okay.
Good morning, everybody. My name is Brad Parley, and I'm going to speak a little bit about arc fault circuit interrupters, which have been prevalent in the United States for the last few years. I sent some samples out that hopefully are being passed around. The first one in the plastic encasement is a ground fault circuit breaker. And I think what you observe when you look at that is that one side of the circuit breaker is a thermomagnetic breaker, and the other side is the electronic ground fault piece of it. And I think that's the first thing. And then I also sent around a clear thermomagnetic breaker so you can see how the mechanism works. Feel free to exercise that. It may or may not work because it's been exercised beyond its 10,000 limit. But also I sent around an arc fault circuit breaker, which is what I'm talking about here today. The picture of Gene gave me his little thing. Hopefully I still have it. The picture up here shows the arc fault circuit breakers that are available commercially in the North America market from each one of our competitors. Some of them are visually a bit different, but each one of them incorporates a self-test button or a test button so you can press and see whether or not the electronics in it are working properly or not. For the most part, they're the same kind of configuration. In some cases, there's an LED included that tells you what kind of trip has occurred in case you're trying to do some troubleshooting with the device. What's the best way to advance here? Enter. Yeah, that added a... yeah. Okay. Well, I think this will work. Just going to get everything up there. Oh, boy. I did, and they took me all over the place. All right, let's try it again. I'll have to... we can get it so we can see most of it anyway. I don't know what exactly is going on there. But this kind of shows you the evolution of all kinds of things that occurred in the wiring of homes in the United States. Starting out with the knob and tube, they wrapped a wire around and hot bus out into the home. Then that was replaced with the metal conductor, wrapped conductors as far as the wiring is concerned. Receptacles went from no ground fault or no grounding conductor to including the ground conductor, and then later to incorporating ground fault in some locations in the receptacles and the addition of breakers that Jonathan just spoke about. And also the general circuit protection, the wire protection aspect of things to avoid fires went from basically nothing to fuses to resettable circuit breakers to the inclusion of ground fault and ultimately the inclusion of arc fault circuit breakers. So just a history of change and improvement in the protection that we offer. What we protect against when we're using arc fault circuit breaker is basically these situations where in a lot of cases you have like cords and stuff around the home that aren't protected for years and years and years, and they abrade, and the conductors start to come together in various ways and creating little sparks, which eventually lead up to a heating situation, which then can cause a fire. And I think we've each seen this in our lifetime where something very bad could have occurred or actually did occur as a result of this wear and tear on the wires or some change in the wiring that made the situation worse. These are some pictures. In this case, it was a bad cord or potentially something within the wiring device where the sparks were going for quite a while, and obviously it began to ignite. This is a ceiling fixture like we have here, where the fire began in the wiring here because it was poorly installed, overheated, and eventually ignited. And you have the situations where people are just living and they do things like this where you might drive a nail through the conductor, and that creates another situation where you can get that sparking. And this one's fairly common where you put the cord in and then you back something up to it, and it puts a lot of pressure on the cord and the wires come together. And this causes in the United States roughly 70,000 fires a year. And these result in death, unfortunately, in a lot of cases, especially when the fire begins when people are asleep, because the noxious fumes and all that accumulate before you have time to react to it. In the case of, so this is kind of the review of it. The damaged wires, worn electrical insulation, wires or cords in contact with vibrating metal. That's another situation that where you have like vibrating equipment or something like that. It'll wear the wires or the wire wear internally. Overheated or stressed electrical cords and wires, and misapplied or damaged electrical appliances. If somebody was recycling an appliance or they install it poorly, it can result in a very bad situation. And these are some pictures of some actual, cords and so forth that have suffered this damage. We've all seen this one. We probably all have come close to doing this one. So in general, it's a situation that occurs on a pretty routine basis, and this circuit breaker, protects against that. So if you're thinking about introducing an AFCI standard, and I know IEC has a version of it in there, and they have added it to their recommendations. This is all about safety and life preservation. And a few years ago, when they talked about this early on, the Consumer Product Safety Commission kind of looked at the situation and said, hey, here's an opportunity where technology is now available that we can move to a circuit breaker that's not only protecting the wire and protecting people from shocks.
Just put the mic here because he's going to put the mic there.
Oh, do I need to get closer to the mic? That's fine.
Your sound, it's not clear upstairs, so they want to just put it in the YouTube.
Oh, okay. Yep. I thought I was pretty loud.
You can just talk now.
Okay. So as a result of that study, more was done on the development of the product, and then you can't really introduce a product like that if you don't have sort of a market that's going to use it, right? Because it costs millions and millions of dollars to kind of get it started. And as a result of the various studies, then it went into UL, they developed the standards for it, and then the NEC began to recommend it. And as a result of that, over the years, we've obviously developed it fully, and we've advanced the technology quite a bit. Initially, there was challenges because you're looking at an arcing fault and trying to determine whether or not you have an arcing fault or a ceiling fan or a motor or some other vacuum cleaner kind of device where you've got tons of sparks and everything going on within the armature. You have to determine whether or not that is a problem or if it is an actual out-of-control arcing situation. And so there was more and more development as things went along. And they took the approach, well, this slide actually shows you two kinds of arcing fault, parallel and series. And initially, we only protected against the parallel arcing fault between the conductors. when we got that completely worked out and figured out everything that could happen in the field that would cause a nuisance trip, then we moved on to the series, which was much more difficult to determine. And at the same time, we increased the protection levels significantly. And then we went into another round of commercially viable products. Some nuisance tripping was experienced, but we worked through that, and now we're in the same situation we are with ground fault, where it's very few and far between that we have tripping issues. And I think in terms of general wiring practice, when you introduce these, I've seen wiring installations become much better as a result of these devices. Because if you don't do it right, or if you do it sloppy, the circuit breaker tells the story. And so we have a lot of situations where we say, your breaker is tripping, it's bad. And then you go in and you find out that you've avoided a fire. And it really does help with improving the installations. When we went through this, initially in 1999, there was no requirement for arc fault circuit breakers. In 2002, it averaged 3 per home, and these were basically used in circuits around the bedrooms because we felt like that was a great place to start. There was there was not a whole lot of vacuum cleaners and so forth being attached in those areas that would have been difficult to, or could have caused nuisance tripping. There were areas where people were asleep and could easily be overcome by the smoke before they knew what was going on, or perhaps a smoke detector would go off. So starting with that, we went through it in 2005, 2008, 2011, and now with the 2013 code, it's roughly 14 circuit breakers per home. It's only on R120, or what would be your 220-volt circuits, single pole circuits. And at this point now, we have a requirement for arc fault in the laundry rooms and kitchens, in which case we have a circuit breaker which is coming out as we speak, which includes ground fault and arc fault protection in the same device. And that gives the homeowner several advantages and some added level of safety that they didn't have before. So if you look at this, you can see that we progressively introduced admittedly, there were some growing pains as we went through with nuisance tripping and so forth, but now we all have commercially viable products, and everybody's enjoying the benefits of that safety. If you look at, again, the way we began the process, we had it in the bedrooms initially. This was back in the 2002 timeframe with the thought, again, that this was the place where most people would be injured if a problem arose. But then as it progressed, we included the other living areas that didn't have ground fault because the combined device was, a bit more difficult. And if we move to 2014, this is the list. Basically, all these rooms and areas are now protected by arc fault and or ground fault and arc fault as a requirement. And pretty much the whole house is required. If there's the only holdout at this point is bathrooms, and I think that's just in the next code cycle. I'm not really sure why they didn't include it in bathrooms this go around. And in areas that are unfinished for storage, we don't require it. And that's basically it. Any other questions or?
Can we just leave the question now until Mr. Weber finish?
Okay, sure. I don't know if you know which ones you're or if that's the right area.
Let me get this going here. That's So it wasn't me.
No.
Good morning, everybody, and thank you for allowing me to come back again today. Circuit Breakers has information available to you to help address arc flash. And arc flash is something that was, what happened here was, this is a cable damage curve. you would set the overcurrent protection so it would be low. Air actually becomes a conductor. What this is attempting to show is these two vertical brown pieces are conductors. Not a good drawing, but they're conductors. An arc happens because someone drops a wrench, a wire gets, while somebody's working inside the equipment, something starts the conduction process, and then it goes by itself. What happens is you get high temperatures, 35,000 degrees Fahrenheit. The metal melts. The copper, when it vaporizes, it expands by 67,000 times. And when that happens, you get this explosive force comes out. And it's interesting, when I talk with electricians, they say, I understood that when I touched it, it could stop my heart and kill me. I didn't understand about the arc flash hazard. So there's a lot of things going on, a lot of presentations, a lot of attention being paid to educate people about what arc flashes are and how we can prevent and mitigate them. So a lot of things happen here, and we have tools to help you prevent some of those occurrences. One of the tools out there, the IEEE wrote a standard 1584, and this document is being used worldwide to calculate arc flash energies. What you do is you put in a time and you put in a current and a voltage, and it calculates the amount of energy in calories per centimeter squared as the unit of measurement for energy. The interesting thing about this is it does not have the advantages that circuit breakers give you to help prevent against arc flash hazards. And so we've done testing beyond that to try to show these devices will help you. And there are several published papers. There was a published paper out from NEMA. I co-published a paper with some other folks from Eaton, and I co-published a paper with one of my competitors that we presented at the IEEE conference, the petrochemical industry, PCIC, the IEEE conference. I don't want you to look at this chart and try to read all the numbers here. What this is a bunch of testing that we conducted. See, if you look at this photo on the right, this is a photo of a mannequin standing in front of a piece of electrical equipment when an arc flash happens. And what you see is some sparks flying out. But what you don't see unless you have high-speed film and you have a much higher event is what happens here on the left. The explosion occurs, molten metal comes out, sometimes the doors are expelled. And what this table is a comparison of caloric numbers, the amount of energy that's giving out during these events. And I just want to give you a couple examples here. If I look up in this first row, this is a 250 amp molded case circuit breaker. If I go and do the calculations just based on what is the generic times that are included in the document, I get a very high energy level as shown here in the blue numbers here. When I go one number down, the measured numbers, you can see that it is a fraction of what the calculations would lead you to believe. And that's that way down through this table, that the measured values are always much, much less than what you would get just by calculations. And so why is that? The reason we know that happens is because molded case circuit breakers, when they operate instantaneously, which means they're above the threshold of their pickups and they operate instantaneously, they operate very quickly. And when they operate very quickly, their contacts begin to separate. As soon as their contacts begin to separate, there's an arc that happens inside the breaker. Inside the breaker are arc chutes to break that arc up so that it can interrupt it and stop the flow of current. That happens very quickly, and it also makes another arc that's in series with the accident that's occurring downstream. When the arc flash is occurring down there because someone put a wrench on it, when you start opening up the circuit breaker, this is all happening in milliseconds. It's limiting the current already to what happens downstream. So we know that circuit breakers are very good at current limitation. and that helps you for arc flash. One of the things, when we talk about, yesterday I spoke to you about some of the really big breakers. We call them low voltage power circuit breakers. And those are intended to be able to sit there and ride through a fault until the downstream breaker opens, so that you don't have the main trip out and shut down a whole facility like this because someone plugged too many electrical appliances into the same circuit. You don't want the whole building to go down. You want just the device that's first upstream. So power breakers were made for big facilities to sit there and ride through these overcurrents, and that they have delay settings. As I mentioned, they're tested for a delay setting of 1/2 second, which in an electrical fault situation is a very long time. That's made to sit there so that the one downstream from it opens. One of the things that we have in a lot of these circuit breakers is what's called zone selective interlocking. These big circuit breakers all have electronics in them, and we're able to build intelligence into the electronics of them. And what happens is the breakers in the same zone of protection communicate with one another. And I'm going to give you a little illustration, a little cartoon to demonstrate what I mean. But ordinarily, this breaker up here, set to a 1/2 second delay, will sit there and wait if a fault occurs downstream, because he was intentionally set the delay to provide a coordinated system for the facility. This allows it to bypass some of the settings and make it go faster to limit the amount of energy. So it's called, we use the acronym ZSI, Zone Selective Interlocking. And it was originally developed just to help with coordination purposes and make sure everything's going along well there. But now we recognize that it's very helpful for arc flash, and we've developed the information to help you with your applications. So here is a cartoon, and it's a very simple thing that we show. One main breaker at the very top, several feeder breakers underneath of it. These are in the same zone of protection. They will have a communication set of wires go between breaker to breaker up to the main. And what happens in a situation, you would have a fault occur at this point. When that fault occurs, this first breaker says, I sense that problem because it's downstream from me. Now, bear with me, the breakers don't actually talk to one another. They use communications through digital communications and everything, so they're not audibly saying, I sense trouble. But he is picking up that there's a fault downstream from him. This one here, he doesn't see anything. It's on his line side, so he doesn't do anything. The same with that one, and the same with that one. So without zone selective interlocking, he's normally going to wait for his short second delay time until he opens, because he's trying to be coordinated with the breakers downstream. So he's set for a 1/2 second. He would normally sit there and wait. So with ZSI, with zone selective interlocking, none of his downstream breakers are telling me that they sense problems, so he knows that it's somewhere in between the two. By doing that, he knows I don't want to wait for my downstream breaker to pick it up. I want to go as fast as I can. So that's what he does. Through the communication, he says, I'm not going to wait for my short delay setting because I know the downstream one doesn't see anything. So I'm going to go as quickly as I can. I'm not going to wait. So whenever a fault occurs further downstream, what happens? This guy senses trouble. These two on the left, they don't sense anything, but this guy says, hey, I sense it too. So now I have two breakers sensing it. And again, this was set up for coordination purposes, so he would normally wait a while, let this guy get it. This guy is telling him, I got it, don't worry about it. So he is picking it up, and then coordination is maintained, so only this one trips. So this is the background a little bit of how zone selective interlocking works, and now I'm going to show you what that means to arc flash. This is an example here, and again, it's the same very simple example at the top, a main breaker. Its short delay setting is set at a half a second. These are set for 0.3 second, and there could be many more down in the system that cascade down. The intention is always want to make sure that the one closest to the fault opens up, right? So you set the timings of them to do so. So what happens when a fault occurs? We have, and I just picked an example on a 480-volt system, a 35 kA fault, 35,000 amp fault, which is not unusually high, and this is being done using a calculation method saying for a motor control center, the working distance they assume to be 18 inches unless you know something different. So for that fault, what happens here is without zone selective interlocking, this breaker is going to wait a half a second. At a half a second, it comes up to 43 calories. And when you start looking at the tables that are in the IEEE standards, in the NFPA 70E for electrical safety of personnel, you start saying that number is way too high to protect it. So you may have seen some of these in the industrials. They have these suits that they put on. Some people call them a moon suit. They put a big thing over their head. It's flame retardant clothing that's very heavy to protect the workers' clothing from catching on fire. One of the problems is the heat, and especially in an environment such as yours, when you put this on, the worker's subjected to a lot more heat just from the body heat. So this is a tremendous amount of energy that someone would have to suit up in something like this in order not to get thermally burned by the amount of energy comes out. So that's without zone selective interlocking. With zone selective interlocking, again, this is the communications between the two. This upstream breaker is going to go as fast as he can. As fast as he can in this particular situation is 0.08 seconds. So we've dropped the time down drastically here, and with that, we've dropped the corresponding energy. The energy level comes down to a number of 7 calories. So what this is a difference of putting on a full moon suit and putting on a flame retardant shirt and pants. Much easier for the worker. In fact, many installations in the United States in the petrochem industry, the everyday workwear is a Category 2 flame retardant shirt and pants. So this is an example of what zone selective interlocking can do to help you with arc flash. There are some other technologies that have been developed to also help you with arc flash, and these are in several types of circuit breakers, UL listed circuit breakers. My company makes this in many circuit breakers. We call it an arc reduction maintenance switch. And again, I mentioned that circuit breaker had a half-second delay, and that was done by the engineer to say, I want to make sure all breakers are set properly so that only the one closest to the fault opens settings on the breakers just right. Now, what this allows you to do, this allows a maintenance worker to go in and say, I'm going to do some sort of maintenance in this equipment, but I want a lower amount of energy. While I'm there, I hit this one button. It's a maintenance switch. It automatically overrides all the other settings so that if anything should occur while this person's in there, the time and all the settings go all the way down to their minimum. In fact, this is faster than what the ordinary minimum is because it bypasses all the logic. The breaker knows that if anything happens when a worker's in there, you want that to go off as quickly as possible to limit the amount of energy that happens. You want to prevent damage to the equipment, you want to minimize damage to the equipment, and you want to prevent the employee from being hurt. So in this case, with a normal setting, it's a 10 calorie, and we bring it down to a 2.2 calorie, which is very simple clothing. So another technology advancement in many of the UL listed breakers that are on the market today. Similarly, some manufacturers offer what they call an arc flash mitigation system. And this is a continuous monitoring of the equipment. And some of them are done with light sensors. Some of them use sound sensors to say, when an arc occurs, I want to hurry up and activate something to operate very quickly. And in many cases, what they have is they have a high-speed switch that automatically shuts all of the power to the earth, to the ground. So it takes the energy away from the dangerous arc, which is happening downstream, shunts all that energy very quickly to ground, and it prevents the arc from continuing. Sometimes these are referred to as crowbar devices because they crowbar all the current to ground. So another technology that's been developed to address arc flash hazards. Just a quick summary here is, for the UL listed circuit breakers, use the manufacturer's information. The manufacturers are a very good resource for the users. Go to the manufacturers and use their information that they've developed for their breakers to apply. Like I showed that chart, they could give you application information. Zone selective interlocking is a feature that's been around for many years, well proven in the industry, but now used for another purpose beyond just selective coordination purposes. Arc reduction maintenance switch, another new technology that some manufacturers offer. Talk to the manufacturers, and very similar for arc flash mitigation systems. So that was my very quick overview of arc flash hazards and some of the technology that circuit breakers have today to address it. One other topic that I was asked to address, and I'll go through this one very quickly, we have some new technology out for photovoltaic applications. And photovoltaics are becoming very popular around the world. And we found in UL that we did not have the requirements necessarily for the molded case circuit breakers for that application. So we got together with UL and we wrote out another part of the 489 standard. Jonathan mentioned 489, that's the UL standard for circuit breakers. We made another part to it, UL 489B, and it's very specific to photovoltaic circuit breakers. This document has been published now for several years. It's been out since 2010, and there's already been revisions to it, and it's been refined. So we have this document out there. Many manufacturers offer photovoltaic circuit breakers, UL-listed photovoltaic circuit breakers. And when I go to the IEC 60947-2, today does not have specific requirements for photovoltaic circuit breakers. They are in development. And right now it's in what's called the CDs, the committee draft stage. So it's still going to be a while before that becomes a published standard in the IEC. And they're still working on what those requirements are. So today you can buy UL. We still have to wait for the IEC standard. And then some of the things that are unique for the photovoltaic system, which are very important, these are rated up to 1500 volts DC. The voltages on the photovoltaic systems keep being raised, and this document covers requirements up to 1500 volts DC. And they are also rated, evaluated, and marked for 50 degrees C, because we know that that's very important, the elevated ambient in these applications. So this is something very unique, 50 degrees C applications. And there are vigorous test programs included in the document for the DC testing, the overload, the short circuit, everything you have to do. And one of the big considerations for photovoltaic applications is you now have current going in the reverse direction. So it's something different here. But that is the quick summary of what's important for PV circuit breakers. So just very quickly, another technology that we've developed for our UL listed circuit breakers. And I will leave it to the next person.
the pointer.
Over there. How long it will be take?
لا لا 15 minutes or 20 minutes maximum.
عشان بس time.
لا لا never mind. Good morning. First, I would like to say thank you for giving me an opportunity to introduce myself to you. I'm Ahmed Fahmi, Senior Technical Promoter for ABB Low Voltage Products here in Saudi Arabia. I worked for ABB around 7 years for several positions. Today, continue to our colleagues' workshop, we will talk about the connectivity and the smart grid networks and what ABB can provide in the circuit breakers to provide the smart grid networks. First, industrial process supervision. In the connectivity, now the low voltage circuit breakers in the communication networks are actually required in several systems like large industries, oil and gas systems, automation processes, and smart grids. And it's very important that the circuit breakers in these such systems must have the capability to control and supervise the system. As we will see in the coming slides, that our circuit breakers can provide several protocols in the communication networks. So now, by using ABB circuit breakers, which have highly advanced electronic chip units, we can support several protocols in the communication networks, so the circuit breakers acting as a controlling and supervision the system. This is a very simple diagram. When you have a connection of circuit breakers with the supervision system, the red wire is the power flow and the blue wire is the communication network with the master and slave architecture. What are the advantages by using the circuit breakers or AB circuit breakers in such smart grid networks? Measure the power and energy for cost optimization allocation. Smart metering, as we will see in the coming slides. Measure the power quality of the networks. Remote controlling and monitoring of the circuit breaker. Diagnose the data, which is very important, that measure the percentage of the contact wear. So to schedule preventive maintenance. Also, remote information about the circuit breaker state. All this we will see in the coming slides. So again, the first point to focus on it in the smart grid, that our circuit breakers can provide and communication through around 7 protocols in the communication networks. Frankly speaking, it's a huge number of protocols that we can support. The three basic protocols that we can support, like the Modbus RTU, Profibus DP, and the device net. The Modbus RTU is a very simple protocol and easy to implement. Open protocol, and it's actually used for a supervision system. Application like the BMS and the industrial automation system. We can support this type of protocol in a simple way, integrated in our ABB circuit breakers Emax2, also integrated in our ABB multi-case circuit breakers Tmax, without need of any external converters. Profibus DP is actually used for a supervision and controlling the system. It's based on the master-slave architecture, and the application is mainly used for the factory automation. Again, it's integrated in the ABB Emax2 air circuit breakers without the need of any external converters, and for the multi-case circuit breakers, it's integrated without the need of any external converters. The third protocol that we can provide also is the device net. Device net, again, it's also used for supervision and controlling the system, like the Profibus, but the Profibus is higher data baud rate than the device net. Its application is mainly used for communication between a PLC with the motor starters and the motor controllers in the factory automation as the device net. It's integrated in the ABB Emax2 air circuit breakers, while in the multi-case circuit breakers, it's such need an external converters. So also we can provide. Then, after the three basic protocols appear or arise, and the Ethernet technology. Now, it's very important to know what is the Ethernet technology advantages over other protocols, three protocols. We have several advantages by using the Ethernet technology. First one, it's adopted worldwide. Now, all the buildings now using the intranet and intranet, yes? So now the Ethernet is a big advantage by using this type of protocol. It's the higher data baud rate. It's up to 100 megabyte per second. Simple to use. Common use. As you know, in each communication protocol, it's need a specific type of cable. While in the Ethernet technology, like as we will see in the Ethernet IP, Profinet, IEC 61850, all we can use by using the same type of the cable, without any specific type of cable for each protocol. Simple to integrate to any type of networks, compatibility with many protocols, its ability to connect a very long, more devices in a very long distances, which is very important to apply this type of protocols in the large plant environment. This is the main advantages of using the Ethernet technology. So, in addition, the three protocols that we mentioned, now we have 4 protocols by using the Ethernet communication protocols, like the Modbus TCP, Profinet, Ethernet IP, and IEC 61850. The Modbus TCP is similar to the Modbus RTU, yani it's an evolution of the Modbus RTU for the Ethernet communication protocol. Also, it's used for a supervision of the system. Its application like the BMS building. Modbus TCP is integrated in the ABB air circuit breaker AMAX2 without need of any external converters, while the multi-case circuit breakers only need an external converter, so we can provide. The Profinet and the Ethernet IP. The Profinet is an evolution of the Profibus DP that we mentioned for Ethernet communication networks, and the Ethernet IP is the evolution of the DeviceNet for Ethernet communication networks, and both protocols are used for supervision and controlling the system. And this application like factory automation, communication between PLC and motor controllers and motor starters. These 2 protocols also is integrated in ABB EMAX2 without the need of any external converters. The last one, which is the most important protocol now, and we are unique. We can support the IEC 61850, the communication which is mainly used in the MV substations, the communication between the LV and MV devices. Now we are complying. So, also it's an Ethernet protocol and a communication between the LV and MV devices in an horizontal way through goose messages, in order also to remote controlling the circuit breakers for selectivity communication, also in a vertical communication with each other through the master, which is the SCADA system. So, now, after we have a summary for the communication protocols that the ABB circuit breakers, EMAX2 air circuit breakers, we can provide around 7 protocols. Frankly speaking, it's too much protocols that we can provide in the market. So, after discuss about the communication protocols, this is a very important function which is mainly required to applying a smart grid, where the smart grid is an intelligent grid, where the low voltage devices, specifically the low voltage circuit breakers, must be an intelligent that provide a digital communication to be connected in the smart grid. The smart grid is an intelligent application of intelligence to power distribution, where the smart grid comprises different parts. It's a modern electrical distribution networks. We have different source of powers with different kinds, through utility, through PV, through solar cells, through generators. So we must have a digital communication, remote controlling and monitoring the smart grid, smart metering, and load management and load shedding. All this we will see in the coming slides, how we can provide by using the ABB circuit breakers, EMAX2 in specific. So, what are the advantages of the using of the EMAX2 circuit breakers in the smart grids? As we mentioned, the 7 protocols
of the circuit. And what they're doing is they're comparing the waveform itself, looking for the signature of an arc, and comparing that to known loads that are acceptable, like ceiling fans, like dimmers, devices like that create a acceptable or good arc, and comparing that to known bad arcs. Once that comparison is made, the microprocessor inside the device makes the decision on whether or not to trip the breaker. So they are very different technologies. Some of the devices do use some portion of a ground fault as a portion of the protection methodology, but most of the very difficult protection methodology comes from the waveform signature sensing.
Thank you.
Subhi Salame from Alfanar. Yes, for the GFCI breaker, now it's mandatory to be air slickage and overload and short circuit, or it's enough it's for air slickage because it's used as a branch breaker for inside the load center. So if not used overload and short circuit, it's a protection only for air slickage. And this first question. The second question, if we connect two load after the or three load after this RCBO or air slickage, it can be used or it cannot.
So I think you're asking about are we sensing earth leakage on the device, and how many loads can be connected?
Yes, this is second question.
Okay, so with respect to the quantity of loads connected, the quantity of loads connected to the GFCI devices is not limited. So when they're implemented as circuit breakers, they certainly can be wired in typical applications with multiple receptacles connected. And I'm not sure that I answered the complete question. So
yes, it can be same load. We can after this breaker, it can connect the same load, or maybe can connect AC or different heater, or it must be two heater or AC and heater. It can be or different. The type of the load.
Go ahead. Well, I don't know. I'm the least technical guy, but at the end of the day, as long as the current that went out is the current that comes back, it does not care about the load. So it's a totally, we call it a differential scheme. In other words, if 10 amps are going out, as long as 10 amps are coming back, you could have a heater, a washer, a diverse load set on there, and it would not trip.
Yeah, okay. And for the first question for the RCD, it must be with a protection with the overload and short circuit, or it's enough for air slickage, because it's branch breaker. If there is overload on the branch or the load, the branch breaker will not trip, will go to the main breaker, and the main breaker will trip.
Oh, okay, yeah. So to make sure I've got the question correctly, are the GFCI breakers, do they include normal overload and short circuit protection in addition to earth leakage or ground fault protection? And the answer is that the UL listed per 943 and in addition UL 489, they do include both earth leakage or ground fault protection. In addition to, they also definitely include all the normal circuit breaker functionality of overload, endurance, and short circuit protection. So they act as a normal circuit breaker in addition to acting as a earth leakage or ground fault circuit breaker.
Okay, thank you.
Thank you. Anyone? Doctor? Abdul Hamid?
I thought there would be some tough questions.
Yeah. Well, you're getting sleeping now. Come on, guys.
Abdul Fattah Saleh, Bureau Veritas. Just now we were talking about the 6 milliampere. So I can understand that all UL listed ground fault interrupters are 6 milliampere, or it can be more.
So there's actually two kinds of UL listed ground fault circuit interrupters. The first kind that are designed explicitly and only for personnel protection are 6 milliamp and below protection. Those are designated for ground fault protection. UL also will allow us to have what we call equipment protection devices, and that level is typically defined as 30 milliamps, but they are explicitly not defined for personnel protection. They are explicitly defined for personnel protection. That's actually listed in a different UL standard, and I forget the number, but UL 943 is only for personnel protection, and the limit there is 6 milliamps.
In fact, if I may, the other UL standard, I believe it's 1053, and that's called ground fault protection. And we have acronyms for everything. We call that GFP, ground fault protection, and then some people of equipment. But the term GFCI means 6 milliamps. That's people. GFCI, the rest is just ground fault protection, and really what you're talking about is equipment and things like that.
And it can deal with any type of earthing system, TT system, TN system, whatever the earthing system. Because, you know, we know from our experience that there is some device, it come with too much leakage current, too much like airfall current. So if we will take like up to 5 milliampere, if I'm going to use this one, it will every time interrupt my circuit.
Well, you have to
This
remember.
is why we can see with IEC standard that you will find, okay, you will find 30 milliampere, some circuit breakers up to 10 milliampere, and some adjustable from 5 milliampere to 30 milliampere, depending on your system.
You have to remember that what we're talking about for a GFCI is mainly a one-pole 120-volt device. So for a 127-volt system, you know, we have a two-pole for a 120/240-volt system also. So we're not talking about taking a 5 milliamp device and putting it on a 480-volt system or a three-phase system for a GFCI people shock protection. That is not what we're talking about. That is talking about ground fault for equipment protection. So not 5 milliamp on the higher level systems. That is the low-level residential for shock protection. Just I want to distinguish. They're two different products, two different levels of protection.
But in the panel, I think it's 30 milliampere, the one we install inside the panel, not with the receptacle.
You're talking about a panel and to use for the protection of the devices and the equipment, not the personnel, right?
Yes.
Yeah, well, you're right, and that would be a delineation between devices used for personnel protection and devices that are generic for ground fault protection other than people. They're very different applications and different perspectives.
Thank you.
Gentlemen? Anyone?
One more question again. Regarding again GFCIs. GFCIs are also electronic devices. Some electronic parts are there, or they are electromechanical. Well, I'm asking because in IC we have both types of electromechanical, which is normally two-pole, and then electronic type of earth fault or earth leakage protection in IC, what they call. And there is a trend in some European countries to move away from the electronic because of the reliability issue. So they are moving back towards the electromechanical for this human safety thing or earth leakage protection. So what's the situation in GFCIs?
Yeah, so in the NEMA market, what all of the primary manufacturers are doing is using electronic-based devices for personnel ground fault circuit interrupter protection, the 6 milliamp threshold. They are all electronic devices. With respect to the reliability, what the industry has done in conjunction with the UL and the U.S.-based Consumer Product Safety Commission is identified some of the areas where the device reliability could be improved and have identified improvements to the robustness of the standard from a voltage surge perspective primarily to make the devices more resistant to voltage surges. And in addition, we've also implemented a requirement for self-test of the electronics, where the electronics on a regular basis provides a self-test functionality. And if the device fails that self-test for some reason, a portion of the circuit is not working, it will actually remove itself from service. And so those are a couple of different ways that the electronic devices have a very high reliability.
And I think just to expand on your comment about countries moving away from the electronics, I don't know if that's really the case. I can tell you that I know for a fact that this is a battle that has been going on for before my career started, when electronic devices first came out. And I think Jonathan used the term voltage dependent versus voltage independent. And you'll hear that throughout those IEC committees. This battle has been going on for over 30 years. This one is better, that one is better, rather than they are two devices that are different. And they provide the protection, but it's fuses versus circuit breakers for years. I liken those to a similar, but it's a battle that's been going on and it probably will go on forever just because of competing technologies. Yeah, exactly. Thank you.
Always you're talking about UN. What about IEC?
Well,
About specification standard? I don't know. I missed yesterday. I don't know.
And my focus was on UL, absolutely. And one of the things that I made sure that I said, and I hope I said it several times, I'm not here to badmouth IEC. I was here to promote the continued use of breakers for your installed base. So IEC products for an IEC system, okay. Yeah, I think all the manufacturers make both types of products.
How we can solve the problem now? UL or IEC?
My recommendation in my presentation yesterday, I believe you need to support installed UL NEMA with UL NEMA components and IEC with IEC components. Because if you intermix them, as we discussed yesterday, temperature rise, short circuit, you have unsafe conditions. So it's important to support your installed base. And there's nothing wrong with having, you tell people they need to buy a car, you don't tell them they need to buy a Chevrolet or a Mercedes-Benz. Either one is...
This is safety now.
And both are safe. That is my point. Both are safe when used in their proper entirety. Don't take a...
Since you said it's safe, both, why you couldn't go to IEC? Why UL? Because Saudi Arabia now apply IEC.
As I pointed out, I had some specific examples for a circuit. We were talking about circuit breakers. A circuit breaker, do not take an IEC circuit breaker and put it into a UL assembly. There are dangerous things that can occur from its short circuit current, from its temperature rating. You will have unsafe conditions. It's very important from a safety standpoint that you don't intermix the components within their assemblies. And again, I went through some of the reasons yesterday, specific here.
Since you said that UL is more advanced than IEC in the safety and also,
well,
why you didn't say in lab, as a lab or something like that, you can put UL IEC?
And some products have both ratings on there. Some circuit breakers, I believe, many, I heard ABB, GE, I believe we all make some breakers that have both. The important thing to use those breakers is take the UL ratings, because they have different ratings many times. It's not the exact same ratings. Use the UL ratings in the UL assembly, use the IEC ratings in the IEC assembly. Even though it may be the same product, don't intermix how they're used. That is very important. Because again, things like temperature, short circuit, we discussed several of the specifics. Jonathan talked about some of them for molded case, and I talked about some of them for the power breakers yesterday. But it's the intermixing is where you run into unsafe conditions. And again, I think what you need to do is to continue to support your installed base. If you have an installed base of ANSI NEMA, you should be putting components into that installed base, which are ANSI NEMA. New installations, I think you have to look to your customer base and say, look, is this IEC one meet my needs? If there isn't an IEC photovoltaic circuit breaker, for instance, what is the customer to do? So you have to look at the customer's needs because, again, different customers have different needs. If I look to the petroleum industry's needs are much different than the residential needs.
But now the United States is a part of IEC. Why they don't apply the standard of IEC?
I don't know that I understood.
The United States is a partner of the IEC.
Oh, absolutely.
It's a member.
I am a U.S. National Committee officer. I am very involved in IEC.
Okay, that's what I mean.
Yes.
So why did you discuss this problem with them?
Oh,
What are the differences?
we absolutely have. As I mentioned yesterday, I'm on the low voltage switchgear and control gear assemblies committee. It took us over 15 years to rewrite the IEC standard, at which times, many times I say, creepage and clearance distances in the United States, we need 1 inch, 2 inch. We are 1 vote. America is 1 vote. Western Europe has how many votes? Luxembourg has the same vote value as the United States. So they say, thank you very much, Kevin. And many of the things along the way. Also, with the new standard, I explained yesterday, the assemblies, low voltage assembly standard was 60439. Just in the past 5 years, we've published 61439. It went from a document that was this big to a document that was this big. They asked me, Kevin, why don't you use that? I said, because the UL requirements are this big. And until we cover all of those same features, our lawyers wouldn't let us use a document that has things in it that says, you don't have to run this test subject to an agreement between the user and the manufacturer. We could never get away with that in our marketplace. Never. So they've gone a step, but there's a big step further before the UL system could accept that. So, and what's funny also is we made the step from here to here. Many, there were several people at the committee meetings that said, you are now making people test before they interpreted the standard to say, I don't have to test. And we said, clearly, you have to conduct a short circuit test above a certain level. You have to conduct a short circuit test. And they say, that's not fair. That's not fair to the person who builds in a very small shop down here. But we need to maintain a minimum level of safety. So we're getting there, and maybe someday, but we're nowhere near there on this particular one, the one I'm involved with, low voltage assemblies.
We saw many now standards, IEEE, IEC.
Absolutely.
So why you can't do it like that?
Well, and those took years in the making to do. And some of them, they've harmonized the standard. This particular area has not gone there yet. It's still a long, long way to go. Some of them at the medium voltage area, many of them are, there are several, I don't know what the number is, that are IEC/IEEE. Yes, and that is in the medium voltage area. There are several of them that have been done that way. And I applaud those efforts because they were a lot of work to get there. But
Possible to harmonize about switchgear or interrupters between UL and IEC?
is it possible? We have the technology. do we have the political and the economic and everything? I don't see that happening in the near future because we've spent 15 years to get to this point, and now some people are saying that's too much.
I mean, in Saudi Arabia, is it possible to harmonize both two standards? Could you help us to harmonize?
I don't think it's a simple matter of harmonization. It is a complex matter because they are different. In several cases, you can't say this one is so much better. Some of them, it's easy. For instance, I would say, my opinion, Kevin's opinion, 6 milliamp protection is better than 20. Not that 20 is bad, 20 will save your heart. But if you felt what that feels, this doesn't hurt. That one hurts. So I would say that's a level of better. But if you ask the world to switch to 6 milliamps, they will say no. And they have good reason not to switch because people are not dying. We're not stopping hearts at 20 milliamps. But, you know, they are different. So there are several things. It's not so easy.
It has to be acceptable on both sides. I mean, IEC and UL. If you have a suggestion or, good confidence thing, okay, you can credit me, agree with you.
Okay, Doctor, we can discuss this in the time, but now we have 5 minutes. So the gentleman there, if you can.
Abdul Khaliq Al-Saif from Emerson Appleton Group. Again, I agree 100% of what you said. We have to support our existing installed base. As we are manufacturer of hazardous apparatus especially for oil and gas, just to let you know that we have installed base on almost all of the refineries available in Saudi Arabia, all of the petrochemical plants in Saudi Arabia for SABIC and Aramco. So are we going to continue using ANSI NEMA product in Saudi Arabia? Are we going to allow again issuing SASO certificates for those products which is related to the installed base which you mentioned earlier today?
If that was a question for a decision for me to make, I could give you my answer. I don't think that is my decision. So I would be happy to give you my opinion. Again, my suggestion yesterday was support your installed base that you have going forward. Make your decision what is best for your economy, for your infrastructure. So those are decisions that I can't make. But I can give you my opinion. And specific to hazardous location, my colleague here is an expert on hazardous location. He would love to discuss some of those things with you offline, and maybe we even have a follow-up workshop specific to hazardous locations, because there are such specific items that have to be addressed there. Again, all around safety.
Thank you.
Okay, just, is there any last question? Yes.
My understanding for the UL NEMA standards and IC standards, definitely both the standards, both the philosophies are focused towards safety, no doubt about it. But the difference in approach is that in the American standards, safety is definitely the paramount thing, and American standards guide you towards one solution which is actually designed probably for the worst case. While in case of, for the Europeans, European standard or IC standard, they do a design fit for the job. So normally, they try to economize. Take the same example of the 6 milliamps and 30 milliamps. They define the prime objective is to save the human life, and they put it at 30 milliamps. For you, you want to achieve much higher thing than that. And for you, as you are saying, you don't want even to slightly hurt the guy. So that's why you defined 6 milliamps. Probably this is the difference in the two standards. But definitely, safety is not an issue ignored by either of these standards.
Just as thinking through that, I mean, obviously the 6 milliamp is less, painful or whatever. But in terms of overall safety protection, I think obviously they're both aimed at that. And I think the big difference between the two is a potential problem with the IEC way of doing things. If you sell products that can be applied poorly, in the case of an application where someone's trying to economize, but that product's widely available, then unless you have a very rigorous inspected installation process, then the economized product may end up in the wrong place. And I think with our product, and I don't know if you agree with this situation, but we also have a very rigorous installation inspection process, and we double it by only having one standard in many cases that is the highest and best solution. I think in both systems you could get it wrong, but we have a very good inspection situation. If you in your country don't have a very good inspection situation, then perhaps some of the UL products would be perhaps better, because you end up with a misapplication situation. Kevin, I don't know.
Well, just one last comment I'll make here. We also have things that we're not particularly proud of, and that's a bunch of lawyers. and they pick up on a lot of these things, and our legal system makes us do some of these things to the nth degree that may seem to be overkill, but they are really intentionally looking out for the general user. So just a closing comment.
Okay, thank you very much. Now we have break time around 15 minutes. After that, we will be back here. Gentlemen, we can discuss it later. Thank you very much.
Maybe we can export lawyers to your
Yes? No? I'm busy. Thank you very much.
Are we coming back up?
Yeah. Okay, come on. فيه الين 11 و40 دقيقة تنتهي محاضرته. طبعا انا اتصور انهم لازم يكون هنا بعد يعني 11 و5 يصيرون موجودين هنا، ما اتصور بيجون هنا، يلا بعد 10. ايه اذا
بعد ما في اسئله شبوا عليهم.
ايه في اسئله طبعا، في بعد 11 و40 دقيقة في 30 دقيقة اسئلة.
هذه هي هذه هي خلاص.
اوكي
طيب
يعني
ما في داعي
12 ونص.
عبد الله اليابس موجود هنا.
يا عبد الله يا
بس اذا قبل ولا عبد الرحمن قبل.
كلموا وقولوا له
لانه ما احنا قاطعين محاضره نسلم الدروع
بس
ننزل بوقت.
عشان يكون مجهزين الكاميرا الشباب نبغى نعرف الوقت.
الشباب ما كان عندهم كاميرا اللي يسجلون هناك.
موجود هنا في عندهم كاميرا.
خلاص ما ادري نزلوها من 12 و5 يكون موجود.
مو في واحد قاعد يصور، انا كني اشوف واحد قاعد يصور.
موجود حق الشركه.
اي خلاص اجل عشان
بس تاكدوا من انكم باقي. رتب مع عبد الرحمن عبد الكريم في اسوء الظروف يكون هو.
طيب
نشوف ابو محمد غالبا ما راح
ابو محمد الظاهر
ما يقبل.
لا يا شيخ
كلهم ما يقبلون.
شوفه برا قاعد.
انا بقول له الحين بيقول لك من هو يبغى ينزل 3 دقائق يسلمها ويمشي. ما اقدر اقطع المحاضره والنقاشات واسلم ثم نرجع. اذا طلعوا يا ابراهيم بس خلاص ما
See the article? Breaker got broken? Yeah, the big tail came off. This is the Yes, yeah, and now the next iteration will start to be when you're talking 15. I need help. We'll still be able to press the button. If it doesn't, it's not working. It's good for people laying over for sale.
United States is national, not international. Me too, I would take my
Okay, now we're going to start with Dr. Jean about recommendation and existing and the future needs in Kingdom of Saudi Arabia.
Thank you, Ibrahim. And thank you, Abdul Rahman, for working so hard on this. And everyone who has been involved in organizing this workshop knows how much work it takes to bring a collection of technical experts together, but how important it is to have the technical experts to be able to explain what's happening. Because I can tell you that maybe 4 months ago, I just sketched out some topics that I thought we might have to include in a workshop. And the technical experts said, well, you have to include this, you have to include that, and there's many things that have to be included. So I wanted to thank everyone at SASO who has done a great job in helping us organize this, because when I met with Mr. Al Left back when he visited to the United States in April, we had this concept of doing not just one technical workshop like yesterday and today, but several different technical workshops, because the field of electrical safety is so complicated. Between yesterday's lectures and today's lectures, we heard references to many different IEC standards. We heard references to many different UL standards. We heard references to ANSI, what they called C37 standards for testing. We heard references to IEEE standard this morning. In the world of electrical products, there are many different standards. And thank goodness we have not been doing a workshop on the smart grid, because I can tell you the smart grid roadmap that's been developed now has references to maybe 20 different brands of standards. It's very, very complicated. So I make this review to let you know that the dialogue that we're having today, I think, is the first of many dialogues to cover many different types of electrical products. We know that circuit breakers are a very fundamental safety product to prevent overcurrent. As we learned today, it also prevents shock. As we learned today, it also prevents arc flash if done correctly. And I think the combination of the basic review of circuit breaker technology yesterday and some really good lineups of new technology that's emerging right now when we heard the many new products that are existing reminds us that technology in electrical products is never static. SASO has, I was looking at all of the construction that's going on in Riyadh. And in fact, I arrived at Jeddah, and I was looking at the construction just on the airport area of Jeddah. And I'm thinking, SASO is responsible for the standards for all of this construction. It's an impossible job. But when you look at your job in just the standards for circuit breakers, the job is not completed yet because the technology continues to advance. So we have to have ongoing dialogue to make sure that the products that are available in the kingdom to satisfy the needs of the existing infrastructure, there has to be standards in place to do that. There has to be standards in place to satisfy the needs of the new investment in infrastructure. And when we look at different types of standard systems, they're not always advancing exactly the same level. Some advance, other ones go past it, other ones go past that. So we have to be prepared to work together to be able to identify what is the current state of the art and how does that standard get incorporated in the portfolio of SASO standards and SASO's technical regulations. So that's why we're working here close together like this. I know that we're going to be discussing how we can bridge the differences between the current IEC or the current SASO regulations and what are the differences between some of the UL standards we heard today. I know that Mr. Abdul Rahman and several others in the electrical department of SASO, we are going to be discussing that. Not just today, but I think in the next several months, so that we can get the technical experts from the NEMA member companies to identify where are the differences and how they can be addressed in the products that are introduced into the kingdom. I also would like just to publicly, when I thanked everyone at SASO for helping make this possible, I think you realize that I have been interested in holding more than just one technical workshop. I think that we are learning, for example, there are needs in the petrochemical industry here in Saudi Arabia for hazardous location products. And we have to be able to address the needs in the refineries and in the chemical plants for those hazardous locations to make sure that those workplaces are safe. So I have already been in discussion. The gentleman from Emerson brought up just this morning a little bit, but his colleague from the United States sent me an email last night also about a whole series of standards that are being used in that area. And I discussed very briefly with Mr. Abdul Rahman a list of these standards. So that's a completely different group of work. So I think we have our work in the area of technical standards and testing and certification and certificates of compliance in the circuit breaker arena, but also in other product arenas. And I can tell you that the changes in lighting systems because of the revolution in lighting with the LED, the light emitting diodes, is happening so quickly that is also another area that I think it's important to discuss, because it is not only the safety situation with lighting products, but it's also an issue of efficiency. It's also an issue of color quality. This is a whole new area that has not been addressed. Safety has been addressed, but many of the safety issues that we're involved in, say, incandescent lamps or compact fluorescent lamps or some of the tubular fluorescent lamps, are entirely different issues that are being addressed in today's LED lights. So that's another area that I think we have to do some collaboration into the future. So I wanted to just summarize, as you know, it is not possible to do any workshop without technical experts. I always say that the people from the factory who make the product know more about the product than anybody else. Because years ago I used to work in the steel industry, and we knew more about the steel we were making than any customer, because we had to work with it every single day. So anytime you have, say, constituents of SASO who have questions about technology on electrical products, one of the reasons we want to continue this dialogue and our relationship is for you to be able to ask through NEMA, so that I can ask the technical experts in the factory, what is this technology about? Because it will not be static, and as I said a few minutes ago, the job at SASO is not done to say all our standards are in place, we don't have to do any more work on them. You know there's plenty of work that has to continue to be done. So I'm happy to answer any questions that you may have, but I don't want to wear out my welcome by talking too long. So I will stop here and answer questions. Thank you.
Is there any question, please? No question? Doctor? Okay.
I'll ask one.
Please.
Oh, maybe somebody to get started.
You try to encourage them.
Gene, what do you see as the logical next step? And what time frame are you thinking of for a next step? You mentioned a couple things there, but when I go to a meeting and I walk away, I say, unless we have some action items, it was a nice discussion. So what would you list as an action item?
Oh, we have a lot of next steps. Okay, now it works. It's a green light that makes it work, not the red light.
Green means go.
Green means go. We know that over the last 3 months or 4 months, SASO notified to the WTO a number of proposed technical regulations. And as you recall, a number of those regulations were on assemblies, right? They were not just components, they were assemblies. And our next steps are to identify what are the differences that are called out in those proposed regulations between those call-outs and what's available in the UL-type products. What are the differences in the technical performance, and what are the differences in the measurement of that performance, the testing that has to be done, and what are the differences in the test reports that have to be certified by an independent third party. So I think our next steps are going to be continued technical analysis to be able to point out, to share with the decision makers and the people responsible for putting the standards or the technical regulations in place here at SASO, to provide them information to be able to make the decisions. Of course, I have to start with the good graces of Governor Saad and see when it would be acceptable to do a workshop in a different technical area. I was suggesting maybe 6 months before it gets to be summertime, like maybe in April or May. We might consider doing another 2-day workshop like this on the hazardous location materials or hazardous location products that are completely different. But in the next month, we have to start doing the analysis to start sharing the technical information on circuit breakers. So the circuit breaker work is continuing ongoing. And I think we also have to address how to address the new products that were mentioned today. For example, the photovoltaic circuit breakers, which are entirely different, that we have to address. There has to be some interest here in the kingdom for photovoltaic assemblies. And if there is, then there has to be standards associated with them so that they can be assured that they are safe and they are performing correctly. So because of the different requirements for the circuit breakers for photovoltaics, that has to be added to the agenda of work that has to be done. Did that kind of answer your question? Okay.
There are many UN standards. It's no difference between IEC, not different between many. And there's some of the UN standards also we can't easily harmonize to IEC. So why we need to start like that? I mean, so this is why then we go to the difficulties.
I think that if you look at the standards that UL is adopting right now in the last 1 year, they're starting to adopt IEC 60, whatever number. They even call it UL 60363 or something, whatever it is, okay? So there is a movement in the United States to be adopting IEC standards when the standard has the right requirements to fit the electrical system. And as you know, creating an IEC standard is a complicated effort. It takes 5 years. It takes technical experts from around the world. They have to agree on what the minimum requirements are. But I think what we're seeing is for new electrical products, like, for example, the LED lighting products, because there are no existing legacy standards, there is quicker to get a single IEC standard that covers the needs all over the world than for products that have been existing for 50 years, for example, like the circuit breakers. So it takes a longer time to harmonize where you have products that have been around a long time than it does for brand new products that are just emerging into the marketplace. I will say, for example, to give you a very good example, motors have been around for over 100 years, electric motors, right? And many people know there's a famous NEMA motor standard, MG1, and then an IEC standard for motor. Interestingly enough, the tables that are used in the NEMA efficiency for motors and the tables that are used in IEC for efficiencies are identical because the technical experts in the motors have put their heads together and agreed 100% what the efficiency values should be. So that's an example. Even though the standard is 1,000 pages long, in the tables they agree exactly. Also, what they have done, the technical experts for motors, for the testing of efficiency, they have completely harmonized the IEC process for testing efficiency and the IEEE process for testing efficiency. I can tell you it took 7 years for the technical experts to study what the differences were and why the calculations came up with different results so that they could fix the testing protocols so that the results were the same. And this is a kind of, very difficult, and it takes a while to make these harmonizations. But the benefits to the consumer and to manufacturers and to the standards authorities like SASO are very valuable, and it's worth the time to take. So I do see, in the time I have been with NEMA, some real progress in having the systems of standards that are the UL system and the IEC getting closer and closer together. Some of the older legacy products will take longer to finish. And as Kevin mentioned, they're getting there if you measure the number of pages. But if the requirements, remember, when people try to harmonize things, you don't want to harmonize to the lowest quality, you want to harmonize to the highest quality. So if there's a difference between the performance under one standard and performance under another standard, you can't harmonize somewhere in the middle, and you can't harmonize down to the lowest level. You have to harmonize to the highest level. So that's where the effort is going right now. We will get there. Yes, sir.
As you know, IEC satisfies minimum safety requirements. And SASO is a full member in IEC. We have the right to modify IEC. My question is, if we modify IEC to satisfy the conditions specified in UL, is it accepted by UL in this case, a new standard?
The U.S. would stand side by side with SASO to do that, okay? But you asked the perfect question, is it acceptable to UL? And that's because the intellectual property that's contained in the UL standard is the intellectual property of UL. So they have to make that decision. All of us could say, we want to see it come about. We want to see IEC make the change, but we have to have the collaboration and cooperation of UL to make sure that happens. I would say, for the most part, UL is the customer, or many of the manufacturers of electrical products are the customers of UL, so they will tell UL how they want the standard to finish up. And I see the manufacturers throughout the world are moving to making higher quality and higher efficient products. They are moving in that direction generally. So if there is, if some of you in SASO want to approach IEC to make a change in the standard, NEMA will be happy to work with you. And we will bring the technical experts, whether it's this type products or other products, to work with you on that.
Hey, Gene. Morning.
Yes, sir.
My name is Sachin. I'm from Eton. I would like to share with Gene that I'm from the marketing background, and it is very difficult to conclude whether UL is better or IC is better. I understand in the last 2 days session. But being a marketing person, or I have a colleagues who are from sales department, so they have given a targets, and they have to meet the targets, annual targets. Now, I have a customers, I have been in the Saudi market from a long time, and I have a customers like SABIC and Aramco, and they have a need in their projects for the NEMA ANSI products. Now, we have been trying to convince them to switch to IEC range, but it is very difficult because the whole designing of the project was done considering NEMA and ANSI products, right? So definitely we cannot convince them to move to IC for certain projects, not for all. So in that case, now customer says no, since project design has been done considering NEMA and ANSI, so we need NEMA and ANSI products. So there is no scope that we can supply IC range of products. Now, since I have to meet my annual targets, so I'll be happy to supply him NEMA and ANSI products. But there are a lot of debates happening what to supply in those jobs. So I have a suggestion. In next session, whenever we are going to happen the next session, if we can invite some of the delegates from Aramco and SABIC, basically from the end user sides, so that we can get the direct feedback from the end users. What are their feeling and how we are going to see our future, you know? Because I have been listening their words quite a long time, but still we do not have a concrete solution for them. So in next session, if we can invite some of the people from end users so that we can listen them and we can understand what are the difficulty they have while switching from UL to IC and all.
I think that's a great idea, and I know Deeb could also identify customers. I know Mr. Ahmed Fahmy, I think he's behind the thing, could also identify some customers. So of course the customers, who are in the market are very realistic constituents. They're stakeholders in this outcome.
Yes.
So they have to be included in the discussion.
Yeah. Thanks.
Okay, sir. Thank you very much. Can I sit, please?
Yeah, yeah.
Thank you very much. Thank you. We would like to thank all of you, especially Nima. It's really very useful information. And now, so glad to extend plugs by Vice Governor Engineer Fawzi Hakim. Would you kindly just come on the stage? Mr. G, you can.
Thank you very much. I was able to obtain a 5-year visa to visit the king.
Mr. Kevin?
To come back.
I hope so.
I hope you'll let me come back.
Mr. Johnson?
Thank you, Mr. Jin.
Mr. Bradley?
السلام عليكم. أشكر الحضور الحقيقة على حضورهم ومشاركتهم وتفاعلهم في هذه الورشة المهمة، وأسأل الله أنه تكونوا استفدتوا منها الاستفادة المرجوة. وهناك إن شاء الله طريق طويل أمامنا في كثير من الورش والندوات والدورات المفيدة. أبشركم أن الهيئة سيكون لديها مركز للتدريب صدر فيه قرار قبل يومين. المركز هذا حيكون متخصص في الدورات الخاصة بالمواصفات والمقاييس والجودة والمختبرات إلى آخره. ستكون هناك شراكة مع جهات أجنبية زي المعهد البريطاني للمواصفات وغيرهم من الجهات التي لها باع طويل في التقييس، تقدم في دورات ندوات مفيدة إن شاء الله لخارج الهيئة للشركاء. المركز هذا مخصص لخارج الهيئة وليس لداخل الهيئة، ولكن لا يمنع أن موظفين الهيئة يستفيدوا برضو من الدورات التي تعقد في هذا المركز. Thank you very much for your coming and for your effort for the which you did it in 2 days ago. and we would like to continue this cooperation and for the Saudi business and private sector. Thank you very much for all of you, and wish you a good journey and safe journey. Shukran.
البرزنتيشن كلها حتكون ان شاء الله على الويب سايت حق الاساس باذن الله خلال الايام القادمه. يعطيكم العافيه وشكرا على حضوركم. بالنسبه لشهادات الحضور اذا حابين ان شاء الله بنحاول نكتبها على الموقع الوقت اللي بتنتهي فيه. إذا حابين إن شاء الله نعطيكم خبر عنها وبالإدارة المختصة اللي بتسلمكم إن شاء الله الشهادات. شكرا جزيلا.
I've enjoyed it. Very good discussion. Yes, yes. But this is just a start. We need to keep it. Yes, yes. We need to speed.
في جهاز
هذا كان موجود هون اليوم. كنت على قلت لك على هذه اللوجو على السيت وقفوا الشحن على راس البيان الجمركي فوقفوا الشحن وعم بيهددوهم انه بدناش نرجع على نرجع يعني طولوا بالكم بس عشان ملاحظه بسيطه جدا ملاحظه بس على حاطين لوجو زي هذا لا لا
حكم